Hello students, this is grade 10 physics class, chapter 12, electricity. Till now we have completed 3 chapters. Chapter 10, that is the light, reflection and refraction, and chapter 11, the human eye and the colorful world. Then chapter 14, source of energy. Am I right? Yes. So we have completed 3 chapters. In this session we will entering into a new chapter, that is Chapter 12, electricity. What is that? Chapter 12, electricity. So in this chapter, no deleted portions are there. Okay, all portions are we have. No deleted, even single topic is there. Okay, yes, we have full lessons. Okay, so you don't panic. Okay, yes. So that is the chapter 12, electricity. Okay, yes. So what is electricity, sir? So what comes to your mind when you think of electricity? You tell me. See, electricity is very important source of energy in modern times. In modern times, which means nowadays. Because electricity plays very vital role in our everyday activities. Electricity makes our work easier. Okay, for example, at home, the electrical appliances such as television, a refrigerator, air conditioner, fan, a mixie grinder, they all electrical appliances work because of only electricity. Am I right? Because of only electricity. Isn't it? Yes. Next, in medical field, what is that? In medical field, the machineries such as MRI scanner, then ECG, X-ray scanner, and all electrical appliances in medical field are functioning because of only electricity. So electricity plays very important role in medical field also. In medical field also. Is it clear? Yes. Next, the electricity which is used to pull the trains. Am I right or wrong? Pull the trains. So nowadays we have so many electrical trains. Most of the trains are only electrical trains. So the train which is running because of only electricity. So electricity plays very vital role in transport sector. Isn't it? Yes, transport sector. Okay, yes. Next, we use the pump set, which means electric motor to bring out the waters from well or any other water sources. Isn't it? Yes. The electric motor running because of electricity. Am I right? The electric motor running because of only electricity. So the pumping of water which is used for irrigation. So this electricity plays vital role in agriculture field. Am I right or wrong? Agricultural field. Isn't it? Yes. So electricity plays very important role in our everyday activities, even in industries. In industries, electricity is used to functioning the machines, very big sized machines. So the all machines are running because of only electricity. So electricity plays vital role in even industrial field also. Isn't it? What is that? Industrial field also. So electricity is very important source of energy in day-to-day life, in day-to-day activities. Electricity makes our work easier. For example, our forefathers used ural, Tamil we say that is ural, to grind some things. Am I right? Something. But nowadays we use mixie grinder to grind something. So this mixie grinder saves our work, saves our time. So which makes our work easier. Am I right or wrong? Yes. These mixie grinders, they all are running because of electricity. Am I right or wrong? Because of only electricity. So electricity plays very vital role, very important role in our everyday activities. Isn't it? Yes. So without electricity, we can survive. Okay, we can survive on this world, but not easier. Okay, so we can survive on the earth without electricity, but not easier, because electricity makes our work easier. Isn't it? So electricity plays vital role in all department, all field. all sector. Electricity plays very important role even at home, then the medical field, then agricultural field, then transport field, then the industrial sector. Electricity plays very vital role. So that's why I'm telling here electricity is a very important source of energy for our life. So electricity is the essential source of energy to survive on the earth, isn't it? Yes, this is very important introduction about the electricity. Okay, so electricity. What is electricity, sir? What comes to your mind when you thinking of electricity? Generally we say that is current. Am I right? Generally we say that is current. Okay, yes. So what is electricity, sir? Electricity and current both are same in here. What is electricity, sir? Because you have been studying since your lower class. Okay, since 6th standard onwards. Am I right? Yes. See, in this world everything is made up of atoms. Am I right or wrong? This world, everything is made up of atom. For example, this table is made up of atom. This chair is made up of atom. That mobile phone is made up of atom. The fan, the bricks, motor, tube light, the all things in this world, everything is made up of atoms. Am I right? Everything is made up of atom. Isn't it? Yes. So what is an atom, sir? Already we know everything is made up of atoms. Okay, in this world everything is made up of atoms, isn't it? What is an atom, sir? Atom means nothing but very tiny particle. What is that? Atom means nothing but very tiny particle which contains three important, which means three main subatomic particles. An atom contains three main important subatomic particles. So what are they? You tell me, what are they? They are, first one, electron, a proton and neutrons. Am I right or wrong? Yes, very simple. Listen here. In this world everything is made up of atoms. An atom contains three important subatomic particles. First one, electron. Yes, first one, electron. Second one, proton, and third one, neutron. Third one, what is that? Neutron. An atom contains three main important subatomic particles. First one, electron, and second one, proton, and third one, neutron. Every atom contains three main particles: electron, proton, and neutron. Isn't it? Yes. This proton and neutron, which is held firmly at a center of an atom, where center of an atom generally we call it as nucleus. What is that? Nucleus. Then what about the electrons, sir? What about these electrons? Electrons continuously revolving around the nucleus. Electrons continuously revolving around the nucleus. Okay, yes, I'll draw the diagram. You look at here. Okay, yes. So consider, so this is nucleus and this is electrons revolving path. Electrons revolving path, they are. Okay, yes. So this is, consider this is atomic structure. This is atomic structure. This proton and neutron, both particles which is held firmly, which means placed firmly at where? Center of an atom. What is the center of an atom? That is called nucleus. So this is called nucleus. That is called, the center of an atom is called nucleus. Here the proton and neutron. What is that? Proton and neutron, which is held firmly at nucleus, which means at center of an atom. Then what about the electrons, sir? What about the electrons? electrons continuously revolving around the nucleus. So this is nucleus, proton and neutron which is held firmly at nucleus, then the electrons continuously revolving around the nucleus in its orbit like this. These all are electrons. Can you see clearly? Yes. These all are electron. The E which denotes electron. The electrons continuously revolving around the nucleus. Around the nucleus, isn't it? Yes. So first of all, what is that? In this world, everything is made up of atom. Everything is made up of an atom. Atom means nothing but very tiny particles, very tiny particle. An atom contains three main important subatomic particles. First one electron, second one proton, and third one neutron. Okay, yes. This proton and neutron, which is placed at center of an atom. What is that? Center of an atom, that is called nucleus. That is called nucleus. The proton and neutron which is held firmly at nucleus. Is it clear? Yes. Then the electrons continuously revolving. Electrons continuously revolving around the nucleus. Around the nucleus in its path. Or otherwise we can say in its orbit. Is it clear? Yes. This is concept. This is a basic. So what is the link between this current and this atomic structure, sir? You may ask me. What is the link, sir? Look at here. So the electrons continuously revolving around the nucleus. Am I right? Yes. This flow of electrons is called electricity. The flow of electrons is called electricity, or otherwise we can say, simply we say current. The flow of, what is that? The flow of electron is called current. Very simple. Okay, for this situation, that is explanation for the word current, which means electricity. This is not a proper definition. For this situation, I will say the flow of electrons is called current. Okay, the flow of electrons called electricity. The flow of electrons are called electricity. For this situation, that is a definition. Proper definition I will explain later. Is it clear? Yes. So electrons continuously revolving around its nucleus. So this is for one atomic structure. This is for one atom. This is for one atom. But the object contains billions and trillions of atoms. How much? Billions and trillions of atoms. This is for only one atomic structure. But each and every object contains billions and trillions of atoms. So the flow of electrons from one atom to another atom is called electricity. The flow of electrons from generally we say that the flow of electrons. So here flow of electrons from one atom to another atom, that is called electricity. What is that? That is called electricity. Simply are called electricity. Is it clear? Yes, very simple. Next come to this electron. This electron has negative charge. Electron has a negative charge. The negative charge is denoted by the letter, the symbol, that is minus symbol. The electron has negative charge, so that symbol is denoted by minus. Then this proton, the proton has positive charge. The proton has positive charge, so the positive charge symbol is plus. What is that? Plus. Then what about the neutron, sir? You may ask me, what about the neutron, sir? Neutron doesn't have any charge. That has only neutral charge. Only neutral charge. So look at here, the electron has negative charge. The negative charge denoted by letter minus, that is not a letter, it's a symbol, minus symbol. Then proton has positive charge. The positive charge denoted by letter, by the symbol, that is plus. Then the neutron doesn't have any charge, only neutral charge. Okay, only neutral charge. Is it clear? It doesn't have a positive sign or negative sign, that is a neutral sign. Is it clear? Yes. So you may ask me, the electron has negative sign, proton has positive sign. What about the charge of an atom, sir? Am I right or wrong? You may ask me, what is the charge of an atom, sir? Charge of an atom is neutral. An atom has a normal atom has neutral charge. What is that? Neutral charge. Why, sir? Why an atom has neutral charge? Why an atom has neutral charge? Okay, because look at here. So already we know this is atomic structure. This is atomic structure. The electron, the proton and neutron, which is held firmly at nucleus, and electrons continuously revolving around the nucleus, isn't it? Yes. So protons are there, electrons are there, even neutrons also there. Is it clear? Yes. See, the number of protons which is placed in an atom, which is equal to number of electrons present in an atom, which means the number of protons which is equal to number of electrons. That is the reason why a normal atom has neutral charge. A normal atom has neutral charge. So the number of electrons which is placed inside the atom, that is equal to number of protons. What is that? Number of protons. So suppose if an atom contains 10 electrons, so what will be the quantity of protons? The protons quantity will be 10. So the number of electrons which is equal to 10, as well as number of proton also 10. So the number of electrons which is equal to number of proton. That is the reason why a normal atom has neutral charge. The quantity of proton which is present in an atom, which is equal to the quantity of protons which is placed in an atom. That is the reason why a normal atom, what charge? Has neutral charge. Has neutral charge. That's all. These are basic. Is it clear? Yes. You consider this is atomic structure. Everything is made up of an atom. An atom contains 3 main subatomic particles. First one, electron, a proton, second one proton, and third one, that is neutron. Is it clear? Yes. The electron has negative charge. So this negative charge is denoted by the symbol, that is minus. Next, the proton has a positive charge. The positive charge denoted by the symbol, that is plus. Then the neutron doesn't have any charge. It has only neutral charge. That is neutral charge. Is it clear? Yes. This proton or neutron which is held firmly at nucleus. The center, the middle point of an atom is called nucleus. Inside the nucleus, proton and neutrons held firmly. Okay, yes. Then the electrons continuously revolving around the nucleus. Is it clear? Yes. So what is the charge of an atom? The charge of an atom, generally an atom is neutral charge. What is that? Neutral charge. Why, sir? Why? Because the number of electrons which is present in an atom, which is equal to number of protons which is present in an atom. So the quantity of protons which is equal to the quantity of electron, due to which the atom, a normal atom has neutral charge. What is that? Neutral charge. So already we know the electrons continuously revolving around the nucleus. The flow of electrons are called, what is that? That is current. That is electricity. For this situation, that is a definition of electricity. The flow of electrons are called electricity, or otherwise we can say current. What is that? Current. This is not a proper definition as that of given in your NCERT book. For this situation, that is a meaning. That is the meaning of the word electricity. What is that? The flow of electrons from one atom to another atom. That is called electricity. Is that clear? Yes. Okay. Look at here. See, we see so many things are around us. Am I right? So many things are around this world. So many things are there. Some things made up of metal, some things are made up of plastics, and some things are made up of other materials such as polished, what is that? Plastic, polyester, then polythene cover, and so many things are there. Okay, so in this world, so many things are there. Am I right? In this world, so many things are there. Even metals are there, non-metals are there, the gaseous particles are there, then plastics are there, so many things are there. Do you think all things conducts the current? Am I right or wrong? Do you think all things conducts the current, which means allows the current to pass through them? Of course not. Few things only conducts the current. Am I right? What is that? Few things only conducts the current, which means allows the current to pass through them, whereas other few things are not able to conduct the current. Just a few things are conducts the current, which means allows the current to pass through them, whereas most of the things, they do not allow the current to pass through them. Okay, so the material which allows the current to pass through them, what is that? The material which allows the current to pass through them, or otherwise we can say the material which conducts the current, that is called conductor. What is that? That is called conductors. That materials is called conductors. So the material which allows the current to pass through them, that is called conductor. Okay, yes, conductors allow the current to pass through them. Which means we can say the conductors conduct the current. Am I right? What is that? The conductor conduct the current. Is it clear? Very simple. Because already we know what is electricity, which means what is current. The flow of electrons are called current. Am I right? The flow of electrons are called current, or otherwise we can say that is electricity. So the material, note this point, the material which allows the current to pass through them, that materials are called conductors. What is that? Conductors. So the conductors allows the current to pass through them, whereas most of the materials, they do not allow the current to pass through them. They are called insulators. What is that? They are called insulators. Okay, is it clear? Very simple. First one, conductor, what is that? A material which allows the current to pass through them, that is called conductor. The material which do not allow the current to pass through them, or otherwise we can say the materials do not conduct the current. That is called, what is that? Insulator. Okay, yes. Now let's start with conductors. What is that? Conductors. See, already we know few things only allows the current to pass through them. Okay, for example, all metals are a good conductor of electricity. What is that? Good conductor of electricity. So the example for conductor is, what is that? All metals are good conductor of electricity. Say some example for the conductors, which means metals. Conductor, yes, copper is one of the good conductor of electricity. Silver, aluminum, then nickel, and so many things. Nickel, the manganese, iron. So these all are examples for conductors. So what is conductor, sir? A material which allows the current to pass through them, they are called conductors. So generally all metals are good conductor of electricity. For example, the copper, silver, aluminum, nickel, iron, they all are examples for metals. Okay, they all are good conductor of electricity. Is it clear? Yes. Whereas the insulators such as wood, then plastic, rubber, they all are they do not allow the current to pass through them. They do not allow the current to pass through them. Is it clear? Because they all are insulator. So next question rising here, the very big question, why sir? Why metals allows the current to pass through them? Am I right or wrong? Yes. Why metals only considered as good conductor, whereas why the insulator do not allow the current to pass through them? Actually, is what happening there? That is very big questions. Am I right or wrong? That is very, very important question. So already we know metals are good conductor of electricity. Metals are good conductor of electricity. Why metals only conduct the current? The main important reason is they have free electrons. What is that? They have free electron. That is the reason why the all metals are considered as good conductor of electricity. Good conductor of electricity. One of the very important reason is they have free electrons. They have free electrons. Free electrons. So what is free electrons, sir? What is free electron? Do you think they are free? That is the reason why it is considered as free electrons? No, not like that. What is free electrons? What is free electrons, sir? Okay, yes, look at here. I'll draw the diagram. Okay, yes. So, sorry, I need that space, so I'm going to rub that. So, next we are going to see why the conductor conducts the current. Why the conductor, what happening there? What is happening there? Okay, look at here. So all metals are good conductor of electricity. Why good conductor of electricity? Why they conduct the current? Because they have free electrons. They have free electrons. That is the reason why they all are considered as good conductor of electricity. What is that? That is metals. Okay, yes. Consider, I am going to take a copper wire, which means copper metal, because copper is one of the very, very good conductor of electricity. Very good conductor of electricity, that is copper. Okay, yes. I am going to take copper. Consider copper. So what is the atomic structure? Which means atomic number. What is the atomic number of copper, sir? Copper atomic number, that is 29. Copper atomic number 29. Okay, copper atomic number 29. Is it clear? Yes, very simple. Okay, look at here. I am going to draw that atomic structure. Consider this is nucleus. The proton and neutron, which is held firmly at nucleus, which means placed at nucleus, isn't it? Yes. Yes, consider this atomic structure. So the proton and neutron, which is held firmly at nucleus here. So this is nucleus. That is nucleus, isn't it? Yes. What about the electrons, sir? Because the proton and neutron, which is held firmly at nucleus. What about the electrons? Electrons are continuously revolving. Am I right? Electrons are continuously revolving around the nucleus. Is it clear? Yes. So why there is the round circle, sir? The electrons revolving path. The round circle is an electron revolving path. The electron revolving path around the nucleus is called orbit. What is that? That is called orbit, or otherwise we can say cell, isn't it? Yes, that is cell. All are same meaning, you don't get confusion. The electron revolving path around the nucleus is called orbit, or otherwise we can say that is cell. So after nucleus, the first cell is called K cell. What is that? K cell, and second one L, third one M, and fourth one N. First cell is, okay, after nucleus, the first cell is, which means the first orbit of electron revolving path is called K cell, second L, third M and fourth N. Fourth N. Is it clear? Yes. So what is the atomic number of this copper? Copper atomic number is 29. Copper atomic number is 29. Is it clear? Yes. So what is atomic number, sir? You tell me. What is atomic? What is mean by atomic number? What is mean by atomic number? Which means the copper element has 24 electrons and 24 neutrons. Sorry, 24 protons. Okay, carbon material has 29 electrons and 29 protons. Is it clear? Yes. So already we know the proton and neutron, which is held firmly at nucleus. The electrons only continuously revolving. Okay, here actually how many orbits are there? 4 orbits are there. K orbit, L orbit, M orbit and N orbit. Okay. In each orbit, how many electrons should be presented? You tell me. In each and every orbit or cell, how many electrons should be presented? You tell me. Yes, we can find out by the formula 2n square formula. What is that formula? 2n squared formula. Okay, what is n, sir? What is n? N means nothing but that is number of orbit. Okay, so first one, use this formula. 2 into n means what is that? Number of orbit. You take first orbit. So what will be here? 1 square, which is equal to 2. And consider for second orbit. So 2 into n. What is n? Number of orbit. Okay, you take second orbit. Okay, what is n here? N which is equal to, here n equal to 1, here n which is equal to 2. So 2 into 2 square which is equal to 2 square 4, and 4 into 2 8 electrons should be there. Where? In second cell. Okay, yes. In next one for third orbit, n which is equal to 3. For second orbit, which means for the M cell, the n value is 3. So use n square formula. 2 into 3. 3 square how much? 3 square that is equal to 9. So 9 into 8, how much? 18. So in third orbit, which means in M cell, how many electrons should be presented? 18 electrons should be there. 18 electrons should be there. Okay, next take the fourth cell. Okay, which means the last one, that is N cell. So here what is the N value? N value will be 4 because the fourth orbit, that is N orbit. So here what is the value? What will be the value? 2 into 4 square, because N value is 4. So 2 into 4 square is equal to how much? 4 square how much? 4 square 16. 4 into 4 16. So 16 into 2 32. 16 into 2 32. Okay, so in first cell, note this point, very very important. In first cell, how many electrons should be there? Which means in K cell, 2 electrons should be there. In second cell, which means L cell, how many electrons should be there? 8 electrons should be there. In third cell, which means M cell, how many electrons should be there? 18 electrons should be there. Okay, in fourth cell, what is fourth cell? N cell. Fourth cell, what is that? N cell. In N cell, how many electrons should be there? 32 electrons should be there. How much? 32 electrons should be there. Is it clear? So this is a concept. Okay, this is a concept. Okay, so according this configuration of electronic configuration, these electrons to be filled in each and every orbit. In first orbit, how many electrons should be there? How many electrons should be available? Just 2 electrons should be available. And second one, 8. In second cell, 8 electrons should be available. Next one, the third, 18 electrons. Then fourth one, 32 electrons. 32 electrons. Is it clear? Yes, keep this concept in your mind. Now come to the copper atomic number. The copper atomic number is 29. Copper atomic number is 29. Is it clear? Yes. Consider the first cell. How many electrons to be filled in first cell? This is atomic structure. Copper atomic structure. Copper atomic structure, which means the electronic configuration. The electronic configuration. Okay, yes. The copper atomic number is 29. In first cell, how many electrons to be filled? Just 2 electrons to be filled in first one. Am I right? Yes. But the copper has how many electrons? Copper atom has how many electrons? 29 totally. So 2 electrons filled here. So this is 1, 2 electrons filled there. Okay, yes. So remaining in second cell, how many electrons to be filled? In second cell, how many electrons to be filled? Maximum 8 only. Okay, yes. Consider here 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons filled. Okay, 8 electrons filled. Till now, how many electrons completed? Which means filled. 10 electrons filled. In first cell, 2 electrons filled. In second cell, 8 electrons filled. So totally 10 electrons filled. Is it clear? Yes, 10 electrons filled. Remaining how many electrons are there? 19 electrons are there. Remaining 19 electrons are there. Isn't it? Yes. Come to third cell, which means M cell. How many electrons to be filled in third cell? How many electrons? Yes, maximum 18 electrons. Maximum 18 electrons, but remaining we have how many electrons? Just 19 electrons. Okay, yes. We fill the remaining 18 electrons in third cell here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 electrons filled. In which cell? 18 electrons filled in third cell, that is M cell. Okay, yes. Remaining how many electrons left? How many electrons left? Just only one. That only one electron which is filled in last orbit, which means N cell. Which means what is that? N cell. Actually, how many electrons would be there? Actually 32 electrons should be there, but the copper atomic number is just 29, due to which in last cell, which means N cell, only one electron is present. Where only one electron is present in outermost orbit, which means N cell. Is it clear? Yes. This outermost electron is called free electrons. This outermost electron is called free electrons. Is that clear? Yes. So these free electrons can able to move from one atom to another atom. One atom to another atom. That movement of the charge, or otherwise we can say the movement or the flow of electrons, is called current. The flow of electrons is called current. Is it clear? Yes, very simple. Look at here. So this is called free electrons. That is called free electrons. Is it clear? Yes. The outermost electron is called free electron, or otherwise we can say valence electrons. Valence electrons. Is it clear? So this is for only this is an example for only the copper atomic structure. But all metals are good conductor of electricity because they have lots of free electrons like this. Lots of free electrons in their outer orbit. Note this point, in their outer orbit, which means outer cell. That is called free electron, or otherwise we can say valence electrons. Or else we can say that is what is that? Valence electron. All metals have lots of free electrons. Lots of free electrons. So the free electrons only able to move from one place, which means one atom to another atom. That flow of electrons are called current. The flow of electrons are called current. So what is the concept here? What is the concept here? Here, the material which allows the current to pass through them, that is called conductor. All metals are good conductor. Why metals only conduct the current? Because they have lots of free electrons. Okay, so this outermost electron, the outermost free electron, or otherwise we can say valence electron. All metals have free electrons. That is the reason why metals are considered as good conductor of electricity, whereas the insulator, they don't have like that. They don't have like that. Is it clear? Yes. Bus. Okay, yes. So what is the conclusions are here? So first one, that is, in this world so many things are there. All things do not allow the current to pass through them, which means all things do not conduct the current. Few things only conduct the current. They are called conductors. What is that? They are called conductors. Why? Next question rises here. Why conductors only conducts the current? Am I right? Why conductors only conduct the current? Because the main reason is they have free electrons. They have free electrons. So what is free electrons, sir? You may ask me, what is free electrons, sir? You look at here. Consider copper. Copper is one of the good conductor of electricity. Copper is one of the good conductor of electricity. You consider here copper, for example. The copper atomic number is 29. Copper atomic number is 29. Is it clear? Yes. I'll look at here. So what is atomic number, sir? Which means the copper has 29 protons and 29 electrons. That is atomic number. Okay, yes. Look at here. So this is atomic structure. Here, this is for the copper atomic structure. The proton and neutron, which is placed, which is held firmly at nucleus, and electrons only continuously revolving. Is it clear? Yes. This electrons revolving path around the nucleus is called orbit, or otherwise we can say cell. So this is the first one is a K cell, second one is a L cell, third one is a 4 cell, and fourth one is a N cell. So fourth one is the outermost orbit. Outermost orbit. Is it clear? Yes. So already we know electrons are continuously revolving around the nucleus. How many electrons should be placed in each and every orbit? Okay, we cannot fill for our wish. There is some conditions. There is some rules. So we can fill, note this point, we can fill the electron configuration according to this formula, that is a 2n squared formula. What is that? 2n squared formula. So according to this 2n squared formula, how many electrons should be placed in first orbit? Just 2 electrons. And second orbit 8 electrons to be filled, and third one 18 electrons, and fourth one is 32 electrons. 32 electrons. So already we know the copper atomic number is 29. So in first electron, the maximum amount of electron to be filled is 2 electrons. So 2 electrons filled here. In second orbit, how many electrons filled here? 8 electrons filled. So 8 electrons filled in L cell. In third one, how many electrons to be filled maximum? That is 18 electrons. So 18 electrons filled here. Okay, remaining how many electrons left here? Only 1 electron is left. That 1 electron has filled only in outer orbit. But 32, look at here, maximum 32 electrons to be filled in outer cell, but only 1 electron is filled in outermost orbit. That electron is called, that unfilled electron is called free electrons. That is called free electrons, or otherwise we can say valence electrons. What is that? Valence electrons. So the flow of free electrons is called electricity, or otherwise we can say current. So this unfilled electron is called free electron, or else we can say that is valence electron. So these valence electrons, which means free electrons are able to move from one atom to another atom. So this flow of electrons are called current. So this is how electricity is generated. That's all. Okay, yes, only one main thing is, what is that? The material which conducts the current is called conductor. Why conductor only conducts the current? Because of the conductors have free electrons, or we can say valence electrons. That is the reason why conductors conduct the current. Okay, conductor conducts the current. So all metals are good conductor of electricity. That's all. That is a concept. Okay, yes. Okay, sir, conductor, okay, sir. What about the insulator, sir? You may ask me, what about the insulator, sir? You may ask me, what about the insulator, sir? Okay, so conductor conducts the current because they have lots of free electrons. What about the insulator? That is next one. What about the insulator? So what is insulator, sir? Insulator do not allow the current to pass through them. Insulator do not allow the current to pass through them. To pass through them. That is a concept. Okay, because why, sir? Conductors have free electrons, but insulators do not have free electrons. That is the reason why they do not conduct the current. They do not conduct the current, which means they do not allow the current to pass through them. That's all. Very easy one. Okay, the insulator is directly opposite to conductor. Conductor conducts the current because they have lots of free electrons. But insulator, they do not allow the current to pass through them, which means they do not conduct the current because they don't have free electron as that of conductor. That's all. Okay, so what is the main reason here? They do not have free electrons. They do not have free electrons. That's all. Say some example for insulators, sir. Say some example for insulator. Yes, plastic one of the insulator, rubber is one of the insulator, mica one of the insulator, wood is one of the insulator, glass is one of the insulator, etc. So these all are examples for insulator. The plastic, rubber, mica, wood, glass, they don't have free electron as that of conductor. Conductors have lots of free electrons, whereas insulator don't have free electron. That is the reason why they do not conduct the current. That's all. Okay, yes. So here, what is the main thing, sir? What is the main thing here? The material which conducts the current, that is called conductor. That is called conductor. Okay, why conductor conducts the current? Because conductors have free electrons, or otherwise we can say valence electrons in their outer orbit. Is that clear? Yes. So that is the reason why the conductors conducts the current, because the free electrons are able to move from one atom to another atom. So this flow of electrons are called current, which means electricity. Okay, so whereas come to next one, the insulator. The insulator do not allow the current to pass through them, which means the insulator do not conduct the current because they don't have free electrons. They don't have free electrons in the outer orbit. That is the reason why. Is it clear? Yes. That is the difference between the conductors and insulator. The examples for the insulator is plastic, rubber, mica, wood, glass, and so many things. The examples for the conductor, the all metals, the metals such as the copper, aluminium, silver, gold, nickel, and so many things, even iron, so many things are there. Is it clear? Yes. So that's all about the conductor and insulator. So next one, the types of charges. What is that? Types of charges. So next one, types of charges. What is that, sir? Next, very, very important one. What is that? The types of charges. Very easy one. Okay, look at here. So already we know, in this world everything is made up of atom. In this world everything is made up of atom. An atom contains three main important subatomic particles: electron, a proton, and neutron. Is it clear? Yes. So already we know the neutron doesn't have any charge. The neutron doesn't have any charge. It has only neutral charge. Only neutral charge, but the proton has positive charge. And the electron has a negative charge. Okay, so it has been found experimentally. There are two types of charges. How many types? Two types of charges. First one, that is positive charge. First one, that is positive charge, and second one, that is negative charge. Second one, what is that? Negative charge. So the positive charge is denoted by the symbol plus, and negative charge is denoted by the symbol minus. Okay, So namely we have two types of charges. First one positive charge and second one that is negative charge. What is positive charge, sir? Proton. Proton is a positive charge particle. Next, negative charge, that is electron. Negative charge, that is electron. Okay, so namely there are two types of charges. First one positive charge and second one negative charge. The positive charge symbol is denoted by plus and negative charge minus. Is that clear? Yes. So next we will see the properties of these charges, sir. Properties of these charges, sir. So already we know, you have been studying since your lower class. The like charges repel each other. The unlike charges attract each other. I mean, like charges repel each other as that of the magnetic property. I mean, as that of the magnetic property. Okay, consider the positive charge here plus positive charge. Consider another one positive charge. Another one positive charge. Is that clear? Yes, this positive charge create positive electric field, and this positive charge also create positive electric field. Positive electric field. So when we bring the two positive charges close to each other, what will happen? There will be repulsion. Okay, the force of repulsion here. There will be repulsion. Okay, which means the two charges repel each other. So the like charges or we can say the similar charges. What is that? Similar charges. Similar means nothing but what is that? Same charges. Okay. The like charges repel each other because what is that? This positive charge creates positive electric field. Even that positive charge also creates the same positive electric field. So when we bring the two positive charges close to each other, what will happen? There will be repulsion force. There will be repulsion force. So the like charges or the similar charges repel each other. These like charges may be positive or negative. Not only for this positive, this can be for even negative also. So positive repel each other, even negative also repel each other. So the like charges, is it? Yes. Then what about the unlike charges, sir? Unlike charges, which means the opposite charges. The unlike charges are attract each other. Unlike charges are attract each other. For example, consider this negative charge and one positive charge. This negative charge creates the negative electric field, and this positive charge creates the positive electric field. So when we bring the one negative charge, one positive charge close to each other, there will be attraction. So there will be the force of attraction between the unlike charges. Here there will be attractive force. Is that clear? There will be attractive force. So it is not only for negative positive, even positive and negative also. Okay, so what is the content, sir, here? What is the content? The like charges such as positive or negative repel each other. That is one of the property. Next, come to this one, the unlike charges. The unlike charges, which means opposite charges. One positive, one negative and one positive. The unlike charges, which means the opposite charges attract each other. Okay, so when two opposite charges placed between some distance each other, there will be force of attraction. So this is the property of these charges. So the like charges repel each other. It can be positive or negative. Then the unlike charges attract each other. It can be positive or negative positive. That's all. Is it clear? Yes. Okay. Yes. So the electric charge is denoted by the letter Q. What is that, sir? You may ask me. The electric charge. The net electric charge is denoted by the letter Q. What is that? Q. Okay, note this point, very important one. The electric charge is denoted by the letter Q. Okay, capital Q, that is net charge. Is it clear? Yes. So already we know what is the SI unit of length. What is the SI unit of length? The SI unit of length is meter, isn't it? SI unit of length is meter. What is the SI unit of mass? The SI unit of mass is kilogram, which means kg. Yes. So what is the SI unit of something? What is it? What is the SI unit of, maybe that is a force? What is the SI unit of force? That is Newton. That is Newton. Likewise, the electric charge has SI unit. What is that? The electric charge has SI unit. So what is that, sir? What is the electric charge unit, sir? SI unit. The electric charge SI unit is coulomb. What is that? The very new word for you. You listen here. Coulomb. Electric charge. The electric charge SI unit. Electric charge SI unit is coulomb. C-O-U-L-O-M-B. What is that? C-O-U-L-O-M-B. That pronunciation is coulomb, not column. That pronunciation is coulomb. C-O-U-L-O-M-B. Coulomb. Okay, the SI unit of electric charge is coulomb. This is very, very important one more question. So this coulomb is denoted by letter C, capital C. Okay, look at here. The electric charge is denoted by letter Q, capital Q, that is charge. But the electric charge SI unit is coulomb. Note this point. Electric charge SI unit is coulomb. This coulomb is denoted by letter, that is capital C. What is that? Capital C. Is it clear? Capital C. Is that clear? It's very easy one. You don't panic. Okay, students? Yes. The electric charge denoted by the letter Q. Then electric charge SI unit is coulomb. That coulomb is denoted by the letter, for our convenient to mention in so many places, even in numericals, that is capital C. Capital C. Is it clear? Yes. Look at here. In this world, everything made up of atoms. Already we know very well. Everything is made up of atoms. An atom contains 3 elementary particles: proton, electron, neutrons. Is it clear? Yes. Every atoms, which means every object has some charge. Every atom has some charge. Is it clear? Look at here. Because an electron possesses a charge that is 1.6 into 10th power of 19 coulomb. Look at here. An electron possesses charge. Charge is right here 1.6 into 10th power of minus 19 coulomb. How much? 1.6 into 10th power minus 19 coulomb. So already we know what is coulomb. Coulomb is a charge of, the SI unit of the charge. Already we know coulomb is, what is that? SI unit of the electric charge. So electron also one of the charge. That is negatively charged particle. That is not a matter. Electron also one of the charge. That electron charge is, even single electron charge is 1.6 into 10th power minus 19 coulomb. That is predefined value. Already they found that. You just keep that in your mind. We no need to express that. Okay, we don't want that. We already found that. You just memorize that. That's all. There is no way. Okay, yes. An electron and single electron, which in Tamil we say one electron. An electron possesses a charge is 1.6 into 10th power of minus 19 coulomb. Minus 19 coulomb. Okay, sir. This is for electron. Okay, sir. What about the proton, sir? Because electron has negative charge, but proton has positive charge. If there is charge for electron, there must be charge for electron. There must be charge for proton, isn't it? Yes. And proton. A proton possesses a charge is 1.6 into 10th power of minus 19 coulomb, the same as that of electron. Okay, the electron and proton charge is same. The electron and proton charge is same, that is 1.6 into 10th power of minus 19 coulomb. What is coulomb, sir? Coulomb means nothing but that is charge, the SI unit of the electric charge. So electron also one of the charge, proton also one of the charge. So the charge value is 1.6 into 10th power of minus 19 coulomb. Minus 19 coulomb. Is that clear? Yes, that's all very easy one. See, in Tamil we say, nalla gavanichuko, I'll explain Tamil, okay, because you can get clear idea about this. இந்த வேர்ல்டில் எல்லா திங்ஸுமே எப்படி இருக்கும், ஆட்டம்ஸால் தான் மேட் ஆகிருக்கும். ஆட்டம்ஸில் எல்லா திங்ஸுமே ஆட்டம்ஸால் தான் மேட் ஆகிருக்கும். ஆட்டம்ஸில் ப்ரோட்டான் இருக்குது, எலக்ட்ரான் இருக்குது, நியூட்ரான் இருக்குது. ப்ரோட்டானுக்கு என்ன சார்ஜ்? ப்ரோட்டானுக்கு பாசிட்டிவ் சார்ஜ் ப்ளஸ்ஸு, எலக்ட்ரானுக்கு நெகட்டிவ் சார்ஜ் மைனஸு, நியூட்ரானுக்கு சார்ஜே கிடையாது. இந்த வேர்ல்டில் எல்லா திங்ஸுக்குமே சார்ஜ் இருக்குது. இந்த வேர்ல்டில் எல்லா திங்ஸுக்குமே என்ன இருக்குது? சார்ஜ் இருக்குது. இந்த சாக் பீஸுக்கு ஒரு சார்ஜ் இருக்குது, இந்த மொபைல் ஃபோனுக்கு ஒரு சார்ஜ் இருக்குது, இந்த டேபிளுக்கு ஒரு சார்ஜ் இருக்குது, எல்லா திங்ஸுக்குமே ஒரு சார்ஜ் இருக்குது. பிகாஸ் எல்லா திங்ஸுமே எதெல்லாம் ஆயிருக்கு? எலக்ட்ரான்ஸாலையும் ப்ரோட்டான்ஸாலையும் தான் மேடாக இருக்குது. ஓகேவா? எஸ். ஸோ இந்த ஆட்டமில் இருக்கக்கூடிய ஒரு எலக்ட்ரானுக்கு எவ்வளோ சார்ஜ் இருக்குன்னா, ஒரு எலக்ட்ரானுக்கு எவ்வளோ சார்ஜ் இருக்குது அப்படின்னா 1.6 into 10th power of minus 19 கூலும் அப்படிங்கிற சார்ஜ் இருக்குது. இதை ஆல்ரெடி கண்டுபிடிச்சிட்டாங்க. நம்ம இதை கண்டுபிடிக்கணும் அவசியமே கிடையாது. நம்ம ஜஸ்ட் மைண்டில் வச்சுக்கிட்டால் மட்டுமே போதும். இது எப்படி வந்ததுன்னா நமக்கு என்ன பண்ணாங்க, நமக்கு கொஸ்டின்ஸ் கேட்க மாட்டாங்க போர்டு எக்ஸாமில். ஓகேவா? எஸ். அதே மாதிரி எலக்ட்ரானுக்கு சார்ஜ் இருக்கும்போது ப்ரோட்டானுக்கு சார்ஜ் இருக்கா இல்லையா? இது நெகட்டிவ் சார்ஜ், இது பாசிட்டிவ் சார்ஜ். ஓகேவா? எஸ். ப்ரோட்டானுக்கு எவ்வளோ சார்ஜ் இருக்குன்னா அதே சேம் சார்ஜ் தான் இருக்கும், 1.6 into 10th power of minus 19 கூலும். ஸோ ஒரு எலக்ட்ரானுக்கு எவ்வளோ சார்ஜ் இருக்குது? 1.6 into 10 power of minus 19 கூலும். ஒரு எலக்ட்ரானுக்கு இருக்குது, ஒரு ப்ரோட்டானுக்கு எவ்வளோ இருக்குது? அதே 1.6 into 10 power of minus 19 கூலும் சார்ஜ் இருக்குது. புரியுதா? எஸ், தட்ஸ் ஆல். Okay, an electron possesses energy charge is 1.6 into 10 power of minus 19 coulomb, whereas a proton possesses the charge is 1.6 into 10th power of minus 19 coulomb charge. Is it clear? Yes. This is positive charge, so this is negative charge. Electron is negative charge, and this is proton is a positive charge. Even though the charges are different, which means opposite, they have the same amount of charge possessed. Okay, that's all. Yes. Next we will see that very important one. Okay, sir, you are telling right, sir. Coulomb means nothing but SI unit, sir. Okay, you ask me Coulomb means what is that? SI unit, sir. How many electrons which is constituting in 1 coulomb? That is next question. How many electrons constituting in 1 coulomb? So already we know what is coulomb. Coulomb means nothing but the charge of the SI unit of the charge, electric charge, that is coulomb. 1 coulomb contains how many electrons? Do you know that? I don't know that, but I am going to teach you. Okay, yes, look at here. So already we know coulomb. What is coulomb? Coulomb means nothing but electric charge. Okay, SI unit of electric charge, that is coulomb. Coulomb is denoted by letter capital C. Okay, yes. So the proton has positive charge and electron has negative charge. Is it clear? Yes. So 1 coulomb, how 1 coulomb contain how many electrons or protons? This is not only for electrons, it also for even proton also. Okay, so next question rising here. 1 coulomb contains how many electrons? How many electrons? Do you know that? Yes. Next I am going to find out that. 1 coulomb contain how many electrons? 1 coulomb contain how many electrons? Okay, note this point. 1 coulomb contain how many electrons? That is very big question. Okay, look at here, because already you know what is SI unit of the electric charge, that is coulomb. 1 coulomb contain how many electrons? That is very big question, very important question also. Okay, yes, we can find out how many electrons which is present in 1 coulomb with the help of a formula. With the help of a formula. What is that formula, sir? That is Q equal to NE. That formula is Q equal to Ne. Please note down in your classwork note. This is very, very important formula. This is very, very important formula. Definitely you will get a 1 mark in board exam from this formula. Is it clear? Yes. So we can find out how many electrons constituting 1 coulomb by this formula, that is Q equal to Ne. That is Q equal to Ne. So what is Q, sir? What is Q? So already we know what is Q. Yes, that is, what is that? The charge of, so which means electric charge. Electric charge. What is that? Q means what is that? Electric charge. N, what is that, sir? N means nothing but number of electrons or protons. N means number of electrons or protons. Note this point. This which means electrons. Okay, you don't get confused. Then next E. E, what is the E, sir? What is E? E means nothing but charge of an electron. Charge of an electron. Charge of an electron. Tamil we say ஒரு எலக்ட்ரானோட சார்ஜ் எவ்வளோ, ஒரு எலக்ட்ரானோட சார்ஜ் எவ்வளோ, அதுதான். ஓகேவா? எஸ். Look at here. Now we are going to find how many electron which is constituting of 1 coulomb. 1 coulomb. So we can find out how many electrons which is constituting of 1 coulomb by this formula Q equal to Ne. Okay, there is no way you just memorize that. There is no way. Q equal to Ne. What is Q? Q means nothing but electric charge. Then what is N? N is number of electrons. Number of electrons present in the object. Next one, E. E, what is that? E? E means nothing but that is charge of an electron. An electron means one electron. Tamil say one electron. An electron. Is it clear? Yes. So now I am going to find out how many electron which is constituting of 1 coulomb. Not only for electrons, even that is for also for proton also. Okay. Yes. So Q equal to Ne. So already we know what is Q, sir. What is Q? Q means nothing but that is electric charge. What is the SI unit of electric charge? That is coulomb. Am I right? So SI unit of Q is coulomb. Am I right or wrong? Yes. SI unit of Q is coulomb. Coulomb is denoted by letter C. Coulomb is denoted by letter C. So I am going to use C instead of that Q because the electric charge SI unit is coulomb. So we can use C, which means coulomb, instead of this Q. There is no problem. Yes. So C which is equal to N into E. N into E. Okay, which means what is the 1 C, which means 1 coulomb. 1 coulomb. So I'll write here Q which is equal to 1 coulomb. 1 coulomb. Okay, yes. So 1 coulomb is equal to N into E. So now we are going to find out number of electrons. We need only number of electrons. How many electrons is present in 1 coulomb? So we need to find out only this N value. Okay, yes. What is the E value, sir? E means what is that? E, charge of an electron. What is the charge of an electron? That is equal to 1.6 into 10 to the power of minus 19 coulomb. 1.6 into 10 to the power of minus 19 coulomb. That is the charge of an electron. Already we know very well. Okay. Substitute this value here. So 1C which is equal to, which means 1 coulomb which is equal to N into E value how much? E value 1.6. E value 1.6 into 10 to the power of minus 19 coulomb. So we need N value, which means number of electrons or protons. So when this term comes this side, this multiplication changes into division. So we can get 1C divided by 1.6 into 10 to the power of minus 19 coulomb, isn't it? That is equal to N. Okay, N means what is that? Number of electrons present in 1 coulomb of charge. Okay, yes. So here C cancel. C, what is the coulomb cancel. Okay, so then we can get N which is equal to, so remaining I'll write here. I don't have space. You listen here. So N which is equal to 1 divided by 1.6 into 10 to the power of minus 19. Okay, remaining I'll write here. You don't get confusion. Because I don't have space. Okay, you listen here. So n which is equal to 1 divided by 1.6 into 10 to the power of minus 19. Okay, yes. So when this 10 to the power minus 19 goes numerator, what will happen? This negative changes into positive. So like this. So 1 divided by 1.6 into 10 to the power of plus 19. Plus 19, because so when this denominator goes numerator, this negative sign changes into positive sign. So already you know very well. So we can get 1 by 1.6 into 10 to the power of plus 19. Plus 19. Okay, yes. See, both term multiple with 100, we can get whole number. Both term multiple with 100. Sorry, 10, just 10. So we can get whole number. So 10 divided by 16 into 10 to the power of plus 19. Plus 19. Okay, they both term multiple with 10. So this term multiple with 10. Here this term also multiple with 10. Okay, I don't have space. That's why I have written here. If I write here, you may get confusion. Okay, yes, I have written here. This is for our convenient. This is no need. So both term multiple with 10. So we can get 10 divided by 16. Okay, you further divide both 10 divided by 16. How much? 10 divided by 16, yes, the smallest number, put one dot, add one 0, 16 into 6, how much? 6, 36, 6, remaining 3, 6, 9, 96. So 6 into 16, that is 96, remaining 4. Remaining how much? Remaining 4, yes, add one 0. So 2 into 16, 32, remaining 8, again add one 0, 16 into 5, which is equal to how much? 80, that is equal to 80, remaining 0. So look at here. So 10 divided by 16, which is equal to 0.625. 5 into 10th power of 19 electrons. Electrons are protons. Note this point. I'll drop this. Electrons are protons. Electrons are protons. I no need to write. Just I'll explain. Okay. Yes. So 10 divided by 16, which is equal to 0.625 into 10th power of 19 plus 19. Note this point. 19 electrons. If they ask about protons, you change into protons. Okay, because this is common for both proton as well as electrons, isn't it? Yes. So which is equal to how much? 0.625 into 10th power of 19 electrons. So if you change this dot decimal, we can get 6.25 into 10th power of 18 electrons. 18 electron. So 1 coulomb containing, note this point, very very important, 1 coulomb containing the electrons of how much? 6.25 into 10th power of 18 electrons. Okay, one coulomb charge. Note this point, very 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 important. This is n. N means what is that? Number of electrons. So one coulomb of electric charge containing of how many electrons? 6.25 into 10th power of 18 electrons. 10th power of 18 electron. So what is it meaning, sir? What is that meaning? Which means after this 25, if there is no dot, after this 25, there will be 16 0. How many electrons which is constituting of 1 coulomb? 1 coulomb. Okay, I'll write there 625. After this 625, there will be 16 0, because here the two decimals cancel, so it becomes 16. Am I right? Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is the range. That is the range. So 1 coulomb. Note this point. 1 coulomb containing how many electrons? 6.25 into 10th power of 18 electrons. 18 electrons, which means after 625, okay, look at there, which means after 625, there will be 16 0. How much? 16 0. That much of electrons, which is equal to 1 coulomb of electric charge. 1 coulomb of electric charge. That is very tremendous one, very big one. That is the reason why coulomb is considered as very biggest unit. Coulomb is considered as very very biggest unit. Is it clear? Yes, very very easy. Okay, students. Yes. Note this point, this is very important, this is very important formula. Okay, already we know every object has some charge. This table has some charge, this pencil has some charge, this cloth has some charge, this node has some charge. Every object has some charge. Note this point. If you know this number of electrons present in any object, you can find out what is the charge of that object. What is the charge of that object? Suppose if you know, listen here, consider this is an object, this chalk piece is an object. If you know how many electrons present in this chalk piece, you can find out what is the charge of this chalk piece. Really you can say what is the charge of this chalk piece. Okay, yes, so with help of this formula, Q equal to NE. Is it clear? That's all. Bus. Is there any doubt? Okay, I'll explain again. So I explain in Tamil. Yes, I'll explain in Tamil. Okay. Yes. So electric charge odeya SI unit கூலும். SI unit என்னது? கூலும். ஸோ ஒவ்வொரு எலக்ட்ரானுக்கும் ஒரு சார்ஜ் இருக்குது, ஒவ்வொரு ப்ரோட்டானுக்கும் ஒரு சார்ஜ் இருக்குது, ஓகேவா? ஸோ எலக்ட்ரிக் சார்ஜுடைய SI யூனிட்னா கூலும். ஸோ ஒரு கூலுங்கிறது எவ்வளோ எலக்ட்ரான் சார்? ஒரு குரூப் ஆஃப் எலக்ட்ரான்ஸ் சேர்ந்தது தான் ஒரு கூலும்னு சொல்கிறோம் நம்ம, ஓகேவா? ஒரு குரூப் ஆஃப் எலக்ட்ரான்ஸாக சரி இல்லை ப்ரோட்டான் இருந்தாலும் சரி, ரெண்டுமே நமக்கு காமன் தான். இந்த ஃபார்மில் ரெண்டுக்குமே காமன் தான். எலக்ட்ரான் கேட்டால் எலக்ட்ரான் யூஸ் பண்ணலாம், ப்ரோட்டான் கேட்டால் ப்ரோட்டான் யூஸ் பண்ணலாம், நோ ப்ராப்ளம். ஸோ குரூப் ஆஃப் எலக்ட்ரான்ஸ் சேர்ந்தது தான் ஒரு கூலும். ஸோ ஒரு கூலுமில் எவ்வளோ எலக்ட்ரான்ஸாக இருக்கும் நீங்கள் கேட்கலாம். ஒரு கூலுமில் எவ்வளோ எலக்ட்ரான்ஸாக இருக்கும்? ஒரு கூலுமில் எவ்வளோ எலக்ட்ரான்ஸ் இருக்கும் அப்போ நமக்கு எப்படி கண்டுபிடிக்கலாம் அப்படின்னா, இந்த ஃபார்முலா வச்சு கண்டுபிடிக்கலாம். Q ஈக்குவல் டு NEங்கிற ஃபார்முலா வச்சு நம்ம கண்டுபிடிக்கலாம். Qங்கிறது என்ன சார்? Qங்கிறது என்னது? எலக்ட்ரிக் சார்ஜ். நம்ம என்ன பார்த்தா Qங்கிறது எலக்ட்ரிக் சார்ஜ். இந்த எலக்ட்ரிக் சார்ஜோட யூனிட் என்னன்னா கூலும். எலக்ட்ரிக் சார்ஜோட SI யூனிட் தான் கூலும். இப்போ தான் நம்ம பார்த்தோம் நம்ம எஸ். N அப்படின்னா என்னன்னா நம்பர் ஆஃப் எலக்ட்ரான்ஸ், எவ்வளோ எலக்ட்ரான்ஸ் இருக்குது ஒரு ஆப்ஜெக்டில், எவ்வளோ எலக்ட்ரான்ஸ் இருக்குது, ஓகேவா? நெக்ஸ்ட் ஈங்கிறது என்ன சார்? ஈங்கிறது ஒரு எலக்ட்ரான் இல்லை ஒரு புரோட்டானுடைய சார்ஜ் எவ்வளோ, நம்ம முன்னாடி தான் பார்த்தோம். இட் இஸ் 1.6 × 10⁻⁻19 கூலும், ஓகேவா? ஒரு எலக்ட்ரானுக்கு இல்லை ஒரு புரோட்டானுக்கு எவ்வளோ சார்ஜ் இருக்குது, இது வந்து காமன் தான். இது வந்து மெமரைஸ் பண்ணி தான் வேறு வழியே இல்லை, ஓகேவா? ஸோ இதெல்லாம் தெரிஞ்சிருச்சா? எஸ். இப்போது இந்த ஃபார்முலா அவங்க அப்ளை பண்ணு. ஸோ ஆல்ரெடி நமக்கு தெரியும் Qங்கிறது என்ன? எலக்ட்ரிக் சார்ஜ். இந்த எலக்ட்ரிக் சார்ஜோட SI யூனிட் என்ன? கூலும். எலக்ட்ரிக் சார்ஜோட SI யூனிட் என்ன? கூலுமா? எஸ். ஸோ Q இஸ் ஈக்குவல் டு 1C போகலாம், விச் மீன்ஸ் 1 கூலும்னு போகலாம், ஓகேவா? பிகாஸ் இந்த Qங்கிறது என்ன? எலக்ட்ரிக் சார்ஜோட யூனிட் என்ன? கூலும். ஸோ நமக்கு என்ன தேவை? ஒரு கூலுமில் எவ்வளோ எலக்ட்ரான்ஸ் இருக்குது, இல்லை ஒரு கூலுமில் எவ்வளோ ப்ரோட்டான்ஸ் இருக்குன்னு நமக்கு தேவை, ஓகேவா? எஸ். ஸோ 1C விச் இஸ் ஈக்குவல் டு N × E. ஸோ E உடைய வேல்யூ எவ்வளோ? விச் மீன்ஸ் சார்ஜ் ஆஃப் அன் எலக்ட்ரான், தட் இஸ் 1.6 × -19 கூலும். இங்கே அப்ளை பண்ணால் நமக்கு என்ன இந்த டேர்ம் சைடு வந்தோம்னா என்ன வரும்? டிவிஷனாக மாறிடுமா? டிவிஷனாக மாறினதுனா CC கேன்சல் ஆயிரும். ஸோ 1 / 1.6 × -10⁻19 கிடைக்கும், ஓகேவா? எஸ். ஸோ இந்த டேர்ம் இந்த 10⁻19 மேலே போனால் என்ன வரும்? இந்த நெகட்டிவ் சைன் பாசிட்டிவ் சைனாக மாறிடும், ஓகேவா? ஸோ வி கேன் கெட் 1/1.6 கிடைக்கும். ஸோ இந்த ரெண்டு டேர்மையும் நம்ம 10ஆல் மல்டிபிள் பண்ணோம்னா 10 / 16. ஸோ இந்த 10 / 16 ஃபர்தராக டிவைட் பண்ணோம்னா நமக்கு என்ன கிடைக்கும்? 0.625 × 10⁻+19 எலக்ட்ரான்ஸ் கிடைக்கும். எலக்ட்ரான்ஸ் கிடைக்கும். ஸோ நமக்கு ஃபுல் நம்பரை வேணும்னா ஒரு டெசிமலுக்கு அப்புறம் டாட் வச்சுட்டோம்னா என்ன வரையும்? இங்கே பவரில் ஒன்று குறையுமா? பவர் வந்து 19 வந்து 18 மாறிடும். ஸோ நமக்கு என்ன கிடைக்கும்? 6.25 × 10⁻18 எலக்ட்ரான்ஸ் கிடைக்கும். 6.25 × 18 எலக்ட்ரான்ஸ் கிடைக்கும், ஓகேவா? இதுக்கு என்ன சார் மீனிங்கு நீங்கள் கேட்கலாம். என்ன சார் மீனிங்னு கேட்கலாம், ஆமாவா? எஸ். ஸோ நமக்கு தெரியும் ஒரு கூலும்ங்கிறது ஒரு குரூப் ஆஃப் எலக்ட்ரான்ஸ். ஒரு கூலும்ங்கிறது ஒரு குரூப் ஆஃப் எலக்ட்ரான்ஸ் இருந்தால் ஒரு கூலும் சொல்கிறோம். அந்த குரூப் ஆஃப் எலக்ட்ரான்ஸில் எவ்வளோ எலக்ட்ரான்ஸ் இருக்கும்? எவ்வளோ இருக்குன்னா ஒரு கூலுமில் எவ்வளோ எலக்ட்ரான்ஸ் இருக்கும், இல்லை எவ்வளோ ப்ரோட்டான் இருக்குன்னா 6.25 × 10⁻18 எலக்ட்ரான்ஸ் இருக்கும், இல்லை 18 ப்ரோட்டான்ஸ் இருக்கும், ஓகேவா? ஸோ இன்னும் புரியல அப்படின்னா இந்த 2 டெசிமல் எடுத்துக்கப்புறம் என்ன வரும்? பவரில் 2 குறையுமா? அப்போ 18 16 மாறும். ஸோ இந்த 6 to 5க்கு அப்புறம் எத்தனை 0 இருக்கிற அர்த்தம்? 16 0 இருக்கிறதா அர்த்தம். 16 0 இருக்கிறதா இருக்கும். ஸோ இந்த 6 to 5 ஆஃப்டர் தட் 16 0 அமௌண்ட் இருக்கக்கூடிய எலக்ட்ரான்ஸ் எல்லாம் சேர்ந்தது தான் ஒரு கூலும். எவ்வளோ இருக்குது? இது வந்து பில்லியன் ட்ரில்லியன்ஸ் தாண்டி போகும். நம்மளால் சொல்ல முடியும் எவ்வளோ இருக்குன்னு. 6 to 5க்கு அப்புறம் 16 0 இருக்குது, யாராலையும் சொல்ல முடியாது, ஓகேவா? ஸோ இவ்வளோ அமௌண்ட் ஆஃப் எலக்ட்ரான்ஸு இல்லைன்னா ப்ரோட்டான்ஸு சேர்ந்தது தான் ஒரு கூலும், ஓகேவா? ஒரு கூலும் சார்ஜு. வேறு எதுவுமே இல்லை. ரொம்ப காம்ப்ளிகேட் பண்ணி கூட ரொம்ப ஈஸியான ஒன்று தான், ஓகேவா? வெரி ஈஸி ஒன். Okay students, that's all. So this is very important. One more question. 1 coulomb which is equal to 6.25 × 10⁻18 electrons. 6.25 into 18 electrons. That is called 1 coulomb of charge. It can be protons or electrons. That's all. Is it clear? Yes. So this session getting over. In this session we have learned so many things. Okay, once again you summarize that. First one, what is current electricity? The flow of electrons or flow of electric charge is called. For this session, this is a proper explanation. This is not a proper explanation, proper definition. Okay, yes. The flow of electric charge electrons is called electricity, or otherwise we can say current. Okay, yes. So next one, then the material which allows the current to pass through them, that is called conductor. Why conductor conducts the current? Because they have lots of free electrons, whereas the insulator, they don't have free electrons. Isn't it? Yes. So next one, the types of charges. Namely, there are two types of charges. First one, positive charge, and second one, negative charge. So an electron possesses its charge how much? 1.16 10 to the power of minus 19 coulomb, whereas proton also possesses the same charge as that of 1.16 10 to the power of minus 19 coulomb. Is it clear? Yes. 1 coulomb which contain how many electrons, sir? 1 coulomb contain the 6.25 into 10 to the power of 18 electrons. So that is the reason why 1 coulomb is a package of electrons. Package of electrons, or otherwise we can say package of protons. Is it clear? Yes. This is very important question. 1 coulomb which is equal to 6.25 into 10 to the power of 18 electrons. Okay, students? Yes. Thank you for your cooperation. This class getting over. If you have any doubt, note in your classwork note. When you come in the school, you come and meet me. I'll clarify it. Okay, students? Thank you.